Welcome to part 3 of this video. I shall assume you've already watched parts 1 and 2, as in this part we shall be going through the aftermath and HSE report conclusions. After their collision, trains 3 and 4 were subject to thorough examinations. Aside from the damage caused in the collision, their general conditions were described as good. They were substantially constructed by the manufacturer and well maintained by the Alton Towers Resort technical team. Bearings rotated freely and functioned correctly, the couplings between cars functioned as intended, neither contributing significantly to make Train 3 stall in the Staffordshire knot. The ride structure, track and supports were similarly inspected by Jacobs UK Limited. They found no evidence of damage to any of the ride structure, and although track joints had gaps larger than would normally be expected, this would not contribute significantly to reduce the speed of the train. An HSE officer observed thorough tests on the PLC to determine whether this could allow two trains to enter the same block in varying conditions. For example, the resetting of a block stop fault would not allow a train to proceed into an occupied block if the occupied block had not been reset. The results were that only a block occupied reset would allow the PLC to move a train into an occupied block, either using maintenance mode whilst logged in or evac mode not logged in. The design of the Smilers PLC followed best practice in terms of safety and redundancies. Each block is monitored by two sensors in the track at the beginning of a block section. In order for the PLC to detect a train has entered a block and it's become occupied, only one sensor needed to be triggered. Whereas for the PLC to detect the train has exited a block and it's no longer occupied, both sensors must be triggered. It could be argued that it was too easy to apply a block reset with just 3 buttons requiring simultaneous activation. In the ride manual, Gertschlauer do state that technicians should check the status of the entire block before pressing the buttons, but it would not have been difficult to provide an additional cue. CCTV images displayed on screens in the control cabin covered the area where Train 3 had stalled. Only the rear 2 rows of Train 3 were visible, the forward 2 were obscured by the ride structure. Train 3 was also visible from the gantry, on which panel OPP3 was placed. The train is at the furthest point from the gantry and again obstructed by the ride structure. Analysis of local wind data by Building Research Establishment Limited concluded that the wind was gusting to 17 metres per second or 13 miles per hour up to and around the time of the accident. CCTV and later tests confirmed Train 3 stalled due to the energy loss due to the gusting wind. Gertschlauer Amusement Ride's operating instructions states the ride must be shut down if wind force 7 is reached, stormy winds, trees are oscillating. This is at 15 metres per second or 34 miles per hour. Merlin Attractions Operations Limited procedures require a constant 34 miles per hour for the Smiler to be shut down, and as it was only a gusting wind, the ride was being operated within Merlin's operational procedures. On to the ride operations department. These are seasonal workers and likely a high turnover of staff. They receive structured training and assessment. Usually they are responsible for a single ride during their period of employment. Returning workers are also reassessed at the start of each operating season. There are minimum training and learning hours that must be achieved on a particular ride to be permitted to operate that ride. There are detailed documents covering their work, for example the Smiler's Code of Safe Working Practice. This document is not available to view, but based on the expert witness report, this large document carefully details the sequence of all processes or work activities which the ride operator is expected to perform. Given that they are responsible for ride movements when the guests are aboard, the document also puts clear limits to the actions they can authorise. The document is based on sound safety engineering principles and is adequate for the safe operation of the ride in normal mode. As to the Smiler ride operator, they carried out their role in accordance with training and correct procedure. At 1:06 PM they saw a fault and called the technical team to assist, even though this was a simple fault that could be cleared without logging in. They cycled the ride without riders to download the ride ready to add the 5th train. They handed the ride over to the technical team at 1:19 PM and they were returned control at 1:40 PM and dispatched Train 4 with riders. Train 4 was stopped by a block fault at 1:43 PM. The ride operator handed control over to the technical team at 1:44 PM They were returned control at 1:50 p.m. and requested code 0 from central control. This was approved, but this process is a formality and is reliant on the PLC having an accurate understanding of the location of all the trains. The ride operator sought additional confirmation from the technical team present in the control cabin that they could proceed with code 0. Mode 4 allowed train 4 to proceed into the occupied block. It is fair to say that if the ride operator had been observing the technicians and monitors during the period the Smiler was in their operation, they might have spotted the stalled train 3 and helped to prevent the accident. However, it was in no way their responsibility to do so, in the same way it is not necessary for car owners to observe mechanics carrying out an MOT. As such, the actions of the ride operator in no way contributed to the accident, and they were in fact following safe working practice. On to the Technical Services Department. This comprises two main teams with a clear hierarchy. Underneath the Technical Services Director, there is a Mechanical Maintenance Manager and an Electrical Maintenance Manager. The mechanical team are responsible for mechanical issue on rides, such as track and trains, and the electrical department is responsible for electrical issues, such as the computer control systems. Underneath each manager, there are two team leaders, with each team responsible for different rides in the park. Each team comprises 10 to 12 frontline mechanical or electrical maintenance engineers. The Smiler falls under the responsibility of Team 1. As mentioned in part 1 of this series, whilst their full title of maintenance engineer is correct, this is often incorrectly shortened to just mechanical engineer and electrical engineer. Mechanical and electrical engineers usually study an honours degree for over 3 years at university and have the ability to design machines and understand systems to relevant standards using relevant mathematical rules and calculations. Maintenance engineers cannot design and build ride components. In such cases, Alton Towers Resort has to outsource these tasks to engineering companies. In industry, maintenance engineers are referred to as technicians. Whilst they cannot design the rides, they should have detailed understanding of how they work in order to keep them working with an ability to diagnose and fix operational faults. It is worth noting that this misconception still exists with an advert in the summer of 2021 for a mechanical engineer at Alton Towers Resort, which is actually for a technician. This is not to devalue the skill of the technicians, as they need to have a thorough understanding of complex ride systems. At the time of the accident, Alton Towers Resort had 8 roller coasters, the oldest of which dates back to 1992. As such, its PLC and control systems will be significantly different to the Smilers built 21 years later. Think about what your computer and operating system from 1992 looked like. In addition, the 8 roller coasters were built by 5 different manufacturers, each with their own standards. The PLC on the Galactica ride, for example, constantly monitors the condition of the 3 trains and gives up-to-date information on the restraints to the HMI, no matter where the trains are on the ride circuit. The PLC on 13 includes a block timer or timeout fault, whereby a specific fault will be triggered if a train takes too long to pass through a block, rather than just a simple block occupied fault. As such, technicians were recruited with experience from industry. Merlin utilised a shadowing and more experienced technician system to train up the new staff. Only the ability to carry out pre-scheduled, daily and monthly proactive maintenance was checked and audited by team leaders. For example, carrying out the checks on the train restraints and wheel assemblies, ready to add them to the ride system. There is no evidence that when technicians attended breakdown work on a ride, that these tasks had been formally trained out, audited, overseen, or supervised by a member of the management team. Instead, the emphasis in the department was on skills, experience, competence, and qualifications. This is good so long as the personnel in the department can guarantee not to make mistakes. This is the reason why, during surgery, instruments and swabs are counted in and out to ensure that none are left inside the patient. Also, co-pilots double-check the actions of the pilots on commercial airlines. This is all in stark contrast to the ride operations department. In order to minimise ride downtime, there was a salary incentive. A clock in the Smiler's control cabin displayed total downtime during a fault condition. At the time of the Block 3 reset, the Smiler's downtime was ticking at over 30 minutes. Whilst this could be seen as good incentive to make sure ride downtime is minimised, and the technicians develop efficient methods for rectifying fault, This does risk that corners could be cut and safety compromised in order to reopen a ride more quickly. During a breakdown, no single member of the technical team was required to take overall control of the process. The initial fault was cleared by 2 mechanical technicians, joined then by 2 electrical technicians, with the mechanical technicians departing before the ride had reopened. There were various states of knowledge as to the significance of fault alarms, in particular for block faults. The inadequate knowledge led staff to distrust otherwise clear fault signals. The belief had been formed that the PLC was unreliable and their own judgment was inherently more reliable. The technical team would fill in the gaps in their knowledge with assumptions. Although the technicians were the instigators of the accident, in particular Electrical Technician A, who instigated the Block 3 reset, Merlin could not provide or demonstrate what each of the 4 technicians should know or understand with regards as to how to safely perform a manual block reset. Technicians were unclear that the Smiler did not have a timeout fault similar to 13 that would have alerted them that Train 3 had taken too long to clear Block 3. None of the 4 technicians involved in the incident had seen or read the Smiler's original operating instructions, nor had sight of the original risk assessment document for maintaining the Smiler. In the Smiler's first year of opening, 2013, the ride stalled 4 times in the exact same location it did on the day of the accident, the 2nd of June 2015. However, this information was not formally disseminated to relevant staff, and no warning of this problematic section of track had been issued. As a result, it is unfair to lay the blame on the technicians. They carried out their roles in accordance with their training, supervision and environment that Merlin Attractions Operations Limited had created. Although Electrical Technician A did not visually inspect Block 3 for a train before resetting it, he had not been trained in the correct procedure of a block reset and its significance to ride safety. He had no thorough understanding of the faults the Smiler could display and that it did not have the same timeout feature of 13. He was working in a pressured environment whereby the Smiler had been closed for over half an hour and his priority was to reopen the ride as quickly as possible in order to meet performance targets. He was just one of 4 technicians who had been working on the ride, and there had been no requirement or procedure for a single member of this team to have an overview of the ride's status. Based on a witness statement, safe practice whenever a technician arrived at a ride breakdown on the Smiler was to ask for the location of all the trains on the system, but since training was reliant on shadowing, this practice was not necessarily shared with all members of the team. It could be speculated that Merlin had inflated its own perception of the technician's skills and underestimated the level of training, induction and assessment they required in order to maintain and repair the ride safely. In effect, they had failed to carry out a risk assessment of their own current practice, which would have highlighted potential issues. On the 27th of September 2016, Merlin Attractions Operations Limited was fined £5 million for failing to ensure that visitors to Alton Towers Resort were not exposed to material risks to their health and safety. The park fell far short of the standards expected of them. It is likely that the cause of the accident was understood within Merlin relatively swiftly. To maintain good PR, the company provided significant healthcare and support for the 16 riders involved in the accident, and would eventually plead guilty to all the health and safety executives' charges. In the immediate aftermath of the accident, Merlin reviewed the operations of all multi-train roller coasters across their attractions. Those rides that used more than 4 trains were closed to review operations. Soar the Ride at Thorpe Park was closed for a month, as this ride shares many similar features to the Smiler. It uses 8 trains and also has a large station building which fully encloses the first block section of the ride. The Smiler was closed for the remainder of the 2015 season, and when it reopened in March 2016, a new satellite panel had appeared in front of the Staffordshire Knot. It's fair to assume that a block reset now requires buttons to be pressed in 3 locations, with 2 technicians and most likely the team leader involved. That concludes part 3 of this video. Thank you for watching.